Hello friends, myself Dr. Bhupesh Jain. I am a faculty in Department of Civil Engineering of Engineering College Jhalawar. I am teaching here final year course, that is Water Resources Engineering second. Okay. In this course, we will discuss today in my first lecture of this channel uh, regarding regulation of works. What is regulation of works? In this, we will discuss what is regulation of works and what are the structures made to used in the regulation works. Okay, the in detail we will discuss regulation faults and different types of faults. Okay, so let me start my discussion on this. This is first unit of this course, and this is syllabus about the uh, of this first unit. In this first topic is faults, and then the classification of faults. Then we will discuss the design of faults. Then in detail distributed head regulator, cross regulator, escapes and bed bars, etc. These all are regulation structures. Okay. So, what is regulation works? Any structure constructed to regulate the discharge, or full supply level or velocity in a canal is known as regulation work. Mind it, regulation works consist of to control the or regulate the discharge or level or the velocity can be changed or regulate using regulation works. Okay. So, what are the types of various? This diagram shows a typical schematic diagram for to define various types of regulation works. In this is main canal going there, and this is off-take channel coming out from this main canal. In this cross regulator constructed in main canal or parent canal, and this is distributory head regulator that is constructed in off-take channel. Okay, so let's one by one we discuss head regulator or head regulator. Head regulator or head sluice, it is constructed at barrage somewhere here. Cross regulator, head regulator or head sluice, it is constructed at barrage. Cross regulator on parent canal. Distributory head regulator in off-take canal. Canal fall. Here is the fall. Very important structure in canal design is canal fall or drop. It is constructed in main channel or any canal wherever it is required. We will discuss it later. Canal outlets. In distributing canals, there are canal outlets to start the miners, etc. Okay, so all these are regulation works and their locations. Let's have a look about the various purpose. A quick look on the various purposes of these regulation works. Head regulator. What is the purpose of this head regulator or head sluice? To divert water to parent channel from a barrage or pier. Okay, right? Then cross regulator, to head up water in the parent channel to divert some of it in off-take channel. This cross regulator. This is cross regulator. Cross regulator, it is diverting water from main channel to the off-take channel. Is clear? Okay. Distributory head regulator. Here is the distributory head regulator. It is controlling the amount of water flowing in the off-take channel, right? Okay. And this is once again canal fall, and this is canal escape. What is the use of canal escape? Canal escape is used to release the excess water from the canal system. This is canal escape. And then canal outlet. Somehow canal outlet I had not shown, not in this figure. Okay, but we'll discuss in detail later. Okay. So now we discuss what is canal fall. Canal fall is required whenever the designed slope is not matching with the available ground slope. So what we have to do? We have to fill this discrepancy by constructing a drop. So let's have read the actual formal definition of the canal. Whenever the available natural ground slope, this natural ground slope is steep than the designed bed slope. This is your designed bed slope. This is your ground slope. It is steeper than the designed slope of the channel. The difference is adjusted by constructing vertical drop. So you can easily see that's why we need this vertical drop in the canal bed at suitable intervals. Whenever such type of situation occurs, we have to construct the vertical drops or falls. It is not always recommended that you construct a bigger drop at one side, and also at the same time it is also not recommended that you construct so many drops at different sites. So we have to optimize this depending upon the cost of the total cost of the project. It is always recommended to economize the project, so we always select that the number of drops should be minimum, and that even at the same time if the total cost should be minimum. Okay, so the main governing factor is cost only. Okay. Now this structure, if we make a drop, simple we construct a drop, it is not stable. So what we do, such a drop in a natural canal bed will not be stable, and therefore in order to retain this drop, a masonry structure is constructed. Such a structure is called as canal fall or canal drop. Now I hope it is very clear that what is canal fall or drop. Now we will go in various types of falls. There are no definite criteria to classify the various types of falls. As per the development of the technology and the research, we developed so many types of falls. One of the oldest type is Ogee Falls. Then to add, we'll discuss later one by one in all these types of falls, whichever is important. First, you just listen the names of the falls. First is Ogee Falls. Second, let's say Rapids. Then third, trapezoidal notch fall. Then simple vertical drop type or Sarda type falls. Okay, this type fall is very important because it is a modern type of fall that includes all types of considerations. Okay, in my opinion. Okay. Straight glacis falls, Montague type falls. Then at the end, English fall or Rapids. Okay. So first, the Ogee type fall. Okay. The screen is not visible. I have to make some correction. Oh yes, now it is visible. Okay. The Ogee type fall has been one of the first to be tried in the Indian canal irrigations, as I already told you. However, according to the earliest structures provided, the crest of the fall was in the same elevation as that of the upstream section of the canal. Here you can see that this Ogee fall is at the same level of the upstream canal bed. Okay, so what it creates a problem. This caused a sharp drawdown of the water surface on the upstream side. On the sharp drawdown, we can see the drawdown. Drawdown, you know what is drawdown? Drawdown is a lowering of the water level at the upstream side of any hydraulic structure. So this is, let's say this is your drawdown. Okay, so higher drawdown. On the downstream of the drop in elevation added energy to the falling water, which exited the fall as a shooting flow. So this will create here a shooting flow type situation. So these difficulties were removed by by raising the crest. Here in this figure you can see the crest is raised slightly above the canal bed. Okay, so this is a raised crest or improved Ogee type fall. Okay, by raising the crest level of the fall above the upstream canal bed level and providing suitable stilling basins with end sill at the downstream end of the fall which kills most of the excess energy of the living water or helping to form a hydrogen. So this is all about the auger type fall. Okay. Now the rapid fall. This is a typical sketch of rapid fall. It is not it is very effective, but it is very costly. So this is also outdated. The rapid fall was tried in some of the North Indian canals, which were constructed with boulders cemented together with lime. Now the trapezoidal fall. This is typical front elevation of a trapezoidal fall. In this, there is various parts of this trapezoidal fall. It consists of one or more notches in a high crested wall across the channels with this entrance, flat circular lip. Yes, flat circular lip here somewhere. This is trapezoidal section. These are the number of notches, trapezoidal notches here. Now the Sardar type. This is the crest of the Sardar fall types. This is two types of crest: trapezoidal crest, rectangular top. Here the crest is trapezoidal. Okay, and this is various parts of this Sardar type fall. We will discuss it in design part of this Sardar type. Okay, thank you.